Hello. Before we start, I would like to clarify something. A few of you may have noticed that I've kind of rebranded my channel. My explanation is that I just kind of stopped taking content creation that seriously. Um, if some of you really want to see professionally made videos, don't worry, that will come back in a different form. But this page will just be me messing around, just posting random videos because I feel like it. So, yeah, that's my justification. Um, Either way, today I want to check out this tool called Learn Godot. Now, I've developed games in Godot myself for like 2 years now, so I can pretty confidently say that I have some degree of expertise in the engine, not to be too pretentious. There's things I don't know yet, but I really want to take a step back and see how it feels relearning this process. And I guess if you're watching this and you haven't used Godot but are intending to use this, you can kind of like use this as a guide to see whether this is a good way to learn it, I suppose. Um, Take what I say with a grain of salt, though, because I am no genius. I am pretty stupid, so you might not get accurate advice from me. Let's see. Okay. Learn GDScript from zero. Oh, so this is about GDScript. I've not. I've seen a few GDQuest videos. They're pretty good, though I know absolutely nothing about this app. But the official documentation recommends this, so better live up to its name. All right. What code is like. Learning to program can be daunting. Yeah, you want to make video games, so there is no way around learning how to program. Every video game is a computer program. Telling the computer what to do. Programming is the process of writing precise instructions that tell a computer how to perform a task. Okay, games instructions are drawing a life bar or playing a sound. To do any of that, you need to learn a programming language, a specialized language to tell the computer what to do. Okay, so we have this. I think this is this like coded node? I forgot. I know this is made in Godot natively, obviously. So I'm just curious how they made something like this. Um, Programming languages are different from natural ones like English or Spanish. I'm not making the joke. The computer does not think unlike us. It can't interpret what you tell it. You can tell something vague like draw a circle. Which circle where? Which color should it be? How big should it be? True. This is something that a lot of people won't really understand when they're starting out programming. Um, so I'm really glad they made that clarification. The exact drawing coordinates, the radius, the thickness, the color you want the code to do so may look like this. Oh, okay. Okay, this is really cool. It actually does it allow you to manipulate the code? Uh, doesn't appear so. What I really would love if there were like if these were like physical sliders, or at least you could modify it in a non-destructive way, so you can like see the reflected changes. Okay. In the following lessons, you will learn how this code works. For now, we want to give you a sense of what a computer code looks like. In this example, everything matters, each parenthesis, capital letter, period, and comma. That is true. Um, and I think that's something a lot of programming tutorials in general miss. They don't explain kind of like the syntax behind how code works. And I mean, if that's reasonable, if you did that at the start, you would just overwhelm the person. But yeah, a lot of people don't understand like why is there a comma here? Why are there parentheses? Like especially with functions. Like that is something people just beginners struggle at a lot. Well, at least I know I did. I can't speak for everyone, but personally, for the longest time I didn't understand like what functions actually did and like why you needed like parentheses to call them. So yeah, let's see if it does that. How do you give instructions to a computer? Okay, submit. You're right. You learn to code with GDScript. In this course, you learn the GDScript programming language. The name stands for Godot script. It's language by game developers for game developers. You can use it within the Godot game engine to create games and applications. And the language used by games like Domekeeper and Brotato. Engineers at Tesla also use it for their car's dashboard. Seriously? I genuinely didn't know that. Hold on, is my mic coming through properly? Okay. Sorry, I just had to check because that would have been embarrassing. GDScript is an excellent language to get started with programming because it's specialized. Unlike some other languages, it doesn't have an overwhelming amount of features for you to learn. That is true, though it's missing some things that I personally would have loved and something that a lot of people want as well, like traits. But I think as it stands, GDScript, it's like it's a really good balance between simplicity and scalability, in my opinion. Most programming languages are similar. Don't be afraid of being locked in. The concepts you learn in your first programming language will apply to all others. That is true. I'll probably skip over this because I don't. This is just an introduction. I kind of want to get to the part where it actually teaches you. Are programming languages all completely different? No, they have many similarities. This is a course of beginner. If you want to learn how to make games or code but don't know where to start, this course should be perfect. What is this? I guess that's cute. We designed it for absolute beginners, but if you already know another language, it can be a fun way to get started with Godot. Okay. We'll give you the coding foundations you need to start making games and applications with Godot. Please be patient. It will take time before you can make your first complete game alone. Learning to make games takes practice. Creating games is more accessible than ever, but it still takes a lot of work and practice. Do not expect any single course or book to turn you into a professional. Yes, a lot of people say this, but practice. Like, don't rely on tutorials. Code what you know. Really understand the code you write, and that way you'll be able to scale very quickly. And something that I want to add, which is personally what I did to learn, use AI. Before you decapitate me, let me explain what I mean. Don't use AI to write code for you. Use AI as your tutor. Use it to understand your code better. Like, if something confuses you, like for example, I didn't understand what a vector 2 meant for the longest time. That was something I was very confused by. Obviously, there's videos about it that I just didn't know about, and I would have understood it if I, looked for it. But I just gave the AI a code snippet with vector 2, and I asked the AI to explain it to me properly because I genuinely had no idea what was happening, and that helped me tremendously. That gave me a lot of, momentum to really learn the engine. Okay. What and how you learn. In this free course, you will learn the foundations. You need to start coding things like these. Inventory, healing heart, gem sword. What is this? Along the way, we'll teach you some of the mindset you need as a developer. Too many programming courses skip that essential part. True. How to write GDScript code. Essentials, programming foundations to get started. What I really want this tutorial to focus on is how GDScript actually interacts with Godot. Like, because that's a very big nuance that I think a lot of Godot tutorials miss. There's how you interface with Godot, like adding nodes, just drawing collision shapes by yourself, like doing polygons, creating scenes, navigating the scenes, etc. But the way the code actually interacts with those scenes is something very important. Like, I want them to really show that you can have like unique names for variables, how to like avoid putting in like links and so using UIDs for scenes, like just explain what classes are, like when you create a script, where it runs, what the scope of that code is, just that kind of stuff in general. Okay. Practice. Ooh, okay. Let's see what this is. Func, ready. Print welcome. Can you make new lines here? Prepare the code sample for you. For this practice, you don't need to change anything. To test the code, click the run button below the code editor. Hint 1. Click the run button. Okay, that's kind of funny. Checks, run the code. Okay. What if I just type in this? Explain? Oh, wow. It explains the errors. Get this error when you wrote something that is syntactically invalid or are missing something to complete this line of or previous lines of code. Oh, wow. Wait, how did they do this? How do they like you can run GDScript at runtime? I genuinely didn't know that. That's really cool. Hold on. I'll be right back. All right, I'm back. Um, wait. So how do you pause? Okay. Well, let's continue. Your first error. When you program, you're bound to run into errors. Tons of them. But you shouldn't worry. On the computers, errors are a good thing. Okay. At school, maybe you learned that mistakes are a bad thing. Damn, dude. Now that's way too political. Um, alright. Making errors friend. Okay. Error translator. Wow, that is really impressive. Yes. Alright. Practiced. Fix your next error. Okay. This code is incorrect and will cause an error, and when you try to run it, this code defines an empty function named "this code is wrong." To work, the function should use the return keyword. Uh, why? You can also just type and pass, and it will work just fine. Okay. Will this work if I... Okay. Um... I don't think this is a really good example. I think it should have gone with the print example because you say that you define an empty function named "this code is wrong," but like what is a function? What does it mean when a function is empty? What does it mean to define a function? Like these are things that the person doesn't know yet. Especially the function should use the return keyword. Like this is something in their head right now. Like what is return? Why do we need it? So I don't know. I don't know if this example is like perfect, but it's still really good. It teaches you about error handling. But yeah, I fixed this in a completely unintended way, which I don't know if that should be rewarded. I don't know. We stand on the shoulders of giants. As programmers, we rely on a lot of code created by others for us. Every programming language comes with a wealth of features created by other programmers to save you time. We call a bundle of code created by fellow developers a library. It's a bunch of code sitting there waiting for you to use it. Game engines like Godot bundled many libraries together. They provide a massive tool set to save you time when making games. You'll always use a lot of existing code. Calling functions. Oh wait, here it is. A function is a list of instructions with an exact name. We could tell the computer to execute all the instructions in a sequence with that name. Okay, so this is where it talks about functions. So I think I spoke way too early. Calling functions. When you tell the computer to execute a function, we say you call the function, okay? To call a function, you write its exact name followed by an open and closed parentheses. To call the function named show, you would write show. And Godot calling show makes something visible, like a character or an item. The complementary hide function hides the entity. Once... Click the run button. Okay. Alright. Creating a new function is necessary to execute instructions in GDScript. Can you tell me more about the run function? Okay. A function is a bundle of code you can execute anytime. Define a function, you must write the func keyword, the function's name, parentheses, and a colon. Okay, this was really good. This is what I wanted. Like, it explains the actual syntax, and it doesn't throw it in your face. There's a special drop down here for you in case you didn't understand it, and there's an actual visual preview. This is really good. Function arguments. We use parentheses to call functions because you can give the function arguments inside the parentheses when calling it. Okay, but what is an argument? Here's a sprite standing straight. If we call rotate 0.3 function, this character sprite turns by 0.3 radians. What if I click this? Okay. Okay, this is really good. This is also something I was stuck on. I did not understand what radians were when I began using Godot. What about sprite? In computer graphics, a sprite is an image you display on the screen. We generally use this word to talk about moving images like a character, a monster, or an item falling on the ground. Okay, so far really good. Oh wow, arguments let you fine-tune the effect of the function call. They can be optional at times, but functions often require arguments in order to work. For example, calling rotate without any argument would result in error. Without an argument, Godot doesn't know by how much you intend to rotate the sprite. Don't worry about memorizing what arguments each function requires or accepts. As a programmer, the documentation will always be close by for you to refer to. Finally, notice how we use a dot and number 0.3 above. You need to use a dot for this to represent decimal numbers. You can't use commas as they have a different purpose in code. Okay, and there you have what is radians. This is really good. Like this predicts like the questions you're gonna ask, which is amazing. Like in tutorials, it just tells you the instruction. It doesn't explain the why before the how, and this is really well made. I'm surprised this isn't pushed more often. Like, I discovered Godot through the use of Bracky's channel, and don't get me wrong, that tutorial is really great, and without it, I wouldn't be into the Godot engine. But I think if I went with this instead, I would have learned it much faster. Okay. Another example, with the move local x function, you can move the character to its left, to and right. The function takes one argument. Amount of pixels to offset the init. This is a thing? I didn't know that. The complementary function move local y makes the character move up and down. This is one way to move a character in the game, though we'll see more powerful ways to do this later. This is really good. Like this. Most often in tutorials, they will jump straight to using vector 2s, which for people like me is really confusing because most of us don't know what vector is unless you're from some like fancy school, I guess, and well, you're in that grade where you learn it. So the fact that they use these functions, which I didn't know even existed because all tutorials use vectors, that's really great because most people know what x and y is. Like, if you played Minecraft or like any other games where coordinates are relevant, you would know what these are. So, yeah. Oh, yeah, and you can spam it multiple times. I mean, I can see people finding the fact that this wraps around the container a bit confusing, but I think it's fine. Though it would have been nice to have like an asterisk here that says that we move the sprite to the corner of the screen so that it doesn't go off screen. Y move local y moves the character down. With positive values, the code above moves the robot to the right and down. This is probably different than what you studied at school. In math classes, the horizontal axis points to the right, like here, but the vertical axis points up. In video games and generally 2D computer graphics, the vertical axis points down instead. Okay, really good clarification. That confused me as well. How do you call a function? What is the syntax used to call a function in general? You write, okay. You write its name followed by colon. Okay. Ooh, okay. Let's make the character invisible. The robot's invisible, call a function to bring it back. Okay. What if I just run it like this? Explain. Okay. This is a bit vague because it already has a tab, it just doesn't have any instructions. Um, what about this? Misplaced. Okay. You get this error when you wrote something that is syntactically invalid. Okay. You need to be extremely precise when you write code. How to fix this? Okay. Okay. Well, this is a bit vague, but I think this is the best you could really explain this issue. And besides, like, it shows here how to call it, and this error would only really happen if you just completely ignored the lessons. So, yeah, here we go. Let's continue. We make the robot upright. The robot was turned by negative 0.5 radians. You'd make it upright by calling the rotate function. Okay. What if I do this? Why did it allow me to do that? Misplaced and... Okay. Well, they did a really good job with the error explanations, but it can lead to some confusing scenarios. Like, for example, if you're coming from a strongly typed language that doesn't use Python-based syntax, you may be inclined to use the dot comma symbol to end your lines. And in this case, this will throw an error, like normally, but here it doesn't. I'm guessing because like once it's rotated, it just kind of stops checking the code. Like let's say I rotated it multiple times. Oh god. Oh wait. Wow. That is really good. I'm guessing it checks the robot's actual rotation. Drawing rectangle. We'll use the code created by others. Okay. Drawing shapes. Meet the turtle. We present you with a turtle. Okay. Prepared several functions for you. Move forward. Turn right. Makes turtle turn clockwise based. Okay. Turn left. Mm-hmm. Uh-huh. And my headphones just died. That's okay, we don't need headphones. Um. Oh, wow. Okay, this is a bit confusing. Uh, because I don't. Mm, the thing is, like, in this example, all of these instructions, I'm guessing, like, internally they get added to some kind of queue, and then this turtle just executes them when the coroutines are done. But that's not actually how things would work in practice. All these lines get executed in the same frame, so the turtle will just snap from this position here. And I don't know if that's the best way to kind of represent this, but then again, at this stage, like, the person learning doesn't know what await is, or like queues, or like variable declarations, that kind of stuff. So I guess it's reasonable, but I don't know. I guess this is acceptable, but this isn't really how it would work in an actual, script. Okay, drawing a corner. Okay. Uh-huh. Turn right 90, move forward 200. Did it work? Okay. Oh wow. Hints. Uh-huh. Okay, the hints are helpful. Draw a rectangle of 200 by 120. Okay. Let me just do this. So I will put a 90 in here. Move forward. This should work. Okay, good. Drawing a bigger rectangle. Oh, and now you have to write the instructions yourself, so that's really awesome. So you can still test the code even though it's not complete. It's just that this check will fail, so you can still like iterate over it and test to see if you did something wrong, which is really good. That is like a really good way to learn things. So, okay, a height of 260, so turn right. Can you still like right click and oh wow, it even has a context menu. That's crazy. Um is this a thing? Yeah, okay. Okay. I think that's a good enough error message. Um how much does it say? 260, turn right 90. I'm guessing this is a code edit, so you can still just like select things and wrap them. Oh no, not really. That's fine though. I'm pretty sure this uses the same font as the code in Godot as well, which is nice. Alright, let's see if this works. Yep, okay. We're coding your first function. Okay, so this is very interesting. We're covering functions before variables, which is very unusual for any programming course in general. Usually you first learn about variables, then like a classic example is the add function. You create two variables and you input them into an add function and then you return something and maybe you print that to the console. Like that's not the case here. Like the first thing you learn is what functions are, which is really interesting, but I think it makes sense when you think about it. Okay, using the identifier, we can get the computer to execute all the instructions to function as many times as we need. This is what a function call does. In computer programming, we talk about identifiers rather than names. It is because a function name is a label the computer uses to precisely identify and refer to a function or other code elements. Identifiers are unique. You cannot reuse the same name in a given space in your code. If you try to name two functions the same, the computer will raise an error. Okay. Each on a separate line. Both these instructions call another similar function. You could write another function that calls move and rotate for times to draw a square length of 200 pixels. Okay. Every time we call move and rotate, the two functions move forward and turn right are called in sequence. This example may not feel super useful. Here's a more useful, realistic one. A function, draw any square. The following function uses parameters, which we'll explore in the next lessons. Drag the slider to change the square size. That is awesome. And look, it even shows here the function call. Okay. What happens if it's okay, so it's limited by the screen size. So if it's like 20. This is awesome. What I personally would have liked if maybe there was a comment here or like some kind of visual indicator that this size number gets replaced with 20, because that's something a lot of people, especially beginner programmers, don't understand. Like this size here, it's a variable. Like when you pass in 20 in here, all of these sizes get replaced by 20, and that is like a very abstract concept for beginners. So that's something that I wish they would have honed into more. But still though, I think this does a really good job at explaining like parameters. As a visual example, so you can clearly see that like these are dynamic. This does different things depending on what input you give it. Okay. Let's break down how you define a function. A function's definition starts with the func keyword, followed by a space, the function's name, parentheses, and a colon. Okay. The instructions inside the function must all start with the leading tab character. Okay. Indents. Okay. Why do we use functions? Select all that apply. To run multiple instructions in one go. To put in a name? This is a bit vague, but I'll select it to see which one is wrong. Oh, all of them are right. Okay. Names in code have rules. Function identifiers cannot contain spaces. In general, names in programming language cannot contain spaces. The computer uses spaces to detect a separation between different keywords and identifiers. Instead of spaces in GDScript, we use underscores. You saw this already with functions like move forward or move local x. This is convention we follow in GDScript. There's another convention programmers use in some other programming languages. Instead of using underscores, they start words with capital letters, except for the first one. Okay. I think they could have mentioned that this is called snake case, I'm pretty sure. Or no, this is snake case. And this is, I forgot, it's not Pascal case, because Pascal case all of the letters are capital, but this is another case. I genuinely forgot its name because I don't use it. But yeah, that would have been nice to specify here, because if you're gonna see, kebab case or Pascal case or snake case, like you're not gonna know that this is what it's referring to, because some things depend on that. Like in project settings, those are genuine options for what the editor chooses to save the file as default, when you're creating scripts and such. Or like when you're making scenes and you use that little like window to create a root node for the scene, and you can also specify the name of the root node. That gets converted into a case specified by the project settings, so it would be nice if this specified like what these are called. Okay, jump, move forward. Wait, what? What's wrong with... Make 3 new characters. 45-degree turn. Oh, identifiers also have to start with a letter or an underscore. I did not know this. I did not know they couldn't start with numbers, but I don't really know where you'd encounter that in a real code base, because like generally numbers are not used in functions in general. Oh wow. In order to draw multiple squares in different positions, we introduce a new function for a turtle to use. The jump functions picks up the turtle and places it relative to where it is. Oh, okay. Moves the turtle by 100 pixels to the left and 50 pixels down without drawing any lines. Okay. Put a function named draw square to draw one square of length, 200 pixels, and take the function should take no parameters. Okay, use the okay. Will this work? I know this is probably isn't covered, but this is what I do. I statically type all of it. What if I put in a parameter here anyways, and just do like, it's an integer. Will it like do anything? Guess we'll find out. And what if we don't use indentation? I also want to test that. Okay. Move forward. What if we also define something else? Test function. That just doesn't do anything. All right. Let's see. Init block. Okay. What if we add spaces? Oh, I'm guessing something external calls this, but it has a mismatch with the arguments. That's nice. Turn right. Oh, okay. I guess that works. I didn't expect it to work, or I'm pretty sure like there's an error when there's like a mix between tabs and spaces. Maybe I should have made one of them tabs, but like I don't know. Doesn't matter. I'm just testing how well they did this. Drawing multiple squares. Use it to draw 3 squares. Okay. So we can't just do this. I'm assuming like externally it's gonna look for this draw 3 squares function. So we can't just do anything in this one. So yeah. Okay. Draw square, jump 300. Let's see. That is really cool. And I really like how dynamic it is. Like people who are learning to code, they're gonna be so fascinated by the fact that like they threw in this like really satisfying thing together. You know what I mean? Like this is awesome. This really should be pushed forward more often. I mean, it is on the official documentation, so I think that speaks a lot for its quality. But a lot of people won't go to the documentation because then again, like when you're starting out as a programmer, you don't really know the appeal of documentations. It's not really something that you're told to use in your first tutorials. The tutorials just like show you how to use the actual engine. But I wish more people would push this out because I had no idea this existed when I started Godot. We had a function to draw a square of any size or better, any kind of rectangle. A square is specific type kind of rectangle, okay. In previous lessons, we used the rotate function, gave it an argument. Just like rotate, we can also give our functions parameter. Parameters act as placeholders in the function's code. Okay, placeholders. That's a really good explanation. It's not something that I've seen people say very often. They just say that it's a parameter and stop there, but it actually explains what parameters are, even though it covered them already. They work like blank spaces that get filled in each time someone calls your function. When you write a function with parameters, you create a flexible template that can work with different values each time you use it. Let's see how the rotate function is defined and use it as a parameter. Okay. For now, focus on the first line, the function definition. Func rotate radians. Okay. The word radians is the function's parameter. It's the placeholder that gets replaced with the actual value when you call the function. When you call this function with rotate, the computer replaces the name radians and the function with 0.5. Each time you call the function, the replacement happens again. If you call rotate 1.2, radians becomes 1.2. The parameter can be filled with a number, text, or anything else. In this lesson, we'll only use numbers as we have to yet learn about other value types. Okay, that's good. When you write a function definition, the line starting with the func keyword, I really think it would have been better if they just underlined definition and allowed you to kind of see it like here. To add a parameter, you write a placeholder name inside the parentheses. When someone calls your function with a value, every copy of the parameter in the function gets replaced with that value, okay? You can give parameters any name. How you name functions and parameters is up to you. Okay. Okay. Here's an example with a function to draw any square. Alright. Oh wait, we already saw this. Okay. Okay. This is good. No. Function. That's funny. A function can have multiple parameters. You can use as many placeholders as you need to add multiple parameters. Write a column between each placeholder name. For example, func move xy has two placeholders, x and y. Each one gets replaced with its own value when you call the function. But I think they should have mentioned that you also need to call them in the correct order, because that's something like probably a lot of people won't understand at first, but it's fine. I think they'll just figure it out through, just testing. Okay, when you call move 50, 100, every x in the function gets replaced with 50 and every y gets replaced with 100. Okay. Parameters are mandatory. Well, they can also be optional, but... Wait, what? Oh, well, yeah, it's optional to add parameters to your function, but when you're actually calling the function, specifying what the parameters are, or I guess arguments, what the arguments are, it's mandatory by default. You can make optional parameters, but it's not something that is known to the user at this point. What's the correct syntax to define a function with multiple parameters? Okay, it's, yes, that. Draw corners of different sizes. I think I'll do this one and then I'll stop the video because I think I've seen enough. This is a really good tool. Like, that is my conclusion. I'll do this though. Before we create a rectangle of any size, let's first practice a simpler shape. I'll call your function twice with different values. 240 and 120. Your task is to add a parameter named length. Okay. Does it have to be length? What if I just corner size? Because I'm pretty sure you can't just check what the parameter's name is, unless I'm stupid. Yeah. I mean, yeah, it didn't have to be length, but I guess that's irrelevant. Alright. Now let's make the draw corner function even more flexible. We'll add a second placeholder so the angle can also vary. Okay. Method descriptions. I did not notice this. This is also really good. Continue. Drawing squares of any size. Time to write a complete function from scratch. You'll make a function that draws squares of any size. I will call your function of different sizes. Okay. Draw square length. And I guess, yeah, move forward and turn right. Uh, 50, no, 90. All right, let's run it. Oh, that's cool. Continue. Drawing rectangles of any size. Let's create a function to draw rectangles with any length and height. I will call your function twice with different size. Okay, this is cool. This is like where you need to think logically. But this is the solution. Oh, I did not mean to do that. All right. Uh-huh. Continue. Okay. Yeah, this is a really good app. Like 10 out of 10, easily. There's only a couple of nitpicks I have throughout this entire thing. I don't know when it actually begins like covering the Godot engine itself, but if it does, that's amazing. That is really my outtake on this, I guess.